Happy late anniversary, Project Arrythmia. I have a gift for you.
You do know it's been almost 2 months since then, right?
Oh, So every video I posted recently, I've basically been challenging myself. So what is the challenge this time? Making a converter from SVG to a Project Arrythmia Prefab. Why? Because making objects in the game is tedious, and I'd rather spend 3 months coding this instead of actually spending my time making level in the editor, which I made no levels already because I'm a crap. So I started with a new C# Visual Studio project, and I used Tehran's prefab builder so I could export a prefab. However, I can't just shove the SVG file into the prefab builder because it's not actually the correct format. So in order to convert something into the correct format, such as an SVG to a prefab, we have to actually use a parser. The SVG is basically an XML file, so we can use an existing XML parser instead of creating our own. So I used the system XML namespace to read the SVG file and its values, such as names like rect, ellipse, circle, and path, as well as attributes like x, y, width, height, and their values. So now that I could read the SVG file, I had to convert the data from the SVG to a PA object. So I created a class called GameObjectData, and this class is intended to hold values that I put into a Project Arrythmia game object using a namespace called Prefab Builder DLL that Tehran built. I started with something simple like a rectangle, and SVG rectangles have 4 main attributes: x, y, width, and height. So it wasn't hard to assign those, so I just checked if the attribute was x. If so, then I set the x position to that value, as well if the attribute was y. If so, then you get the point basically. However, when I went to do circles, I found out that they have 5 main attributes: cx, as in the x position, cy as in the y position, r as in the radius or the width and height, rx as in the width, and ry as in the height. But a lot of these attributes were basically similar to the rectangle attributes. If I didn't do something soon, I was bound to have a bunch of if statements. So what I did is I used switch statements and their ability to fall through multiple cases. Plus, if I wanted to, I could put them all in the same line to make them more readable like this. Also, I noticed that the SVG has different attributes depending on where the pivot is. If the pivot is on the center, it tends to use these attributes. However, if the pivot is on the top left corner, it tends to use these attributes instead. I could use this information to determine the offset or the pivot of the game object. So now we're here at triangles. However, SVG does not have a triangle object. I had to actually figure out whether a path was actually a triangle. So yeah, that's great. Oh, and we also don't know if the triangles rotate or not. So I rotated every point around the center of the triangle 360 times with a for loop. Then I checked whether 2 of the points were on a horizontal axis or had the same y value. If that was the case, then that would be the rotation for the triangle. Then I had to use the rotated points to recalculate the center and the size of the object. Luckily, I could use the same function on figuring out the exact rotation of a square or a hexagon, if the square of a hexagon was a path, of course. And so I made sure that the shape is a triangle if there's 3 points on the path, a square if there's 4 points, and a hexagon if there are 6 points. But wait a second, Project Arrythmia has right triangles as well. To check if the object was a right triangle, all I had to do was check if the top point was on the same vertical axis or x position as one of the bottom points. If so, then it was a right triangle. So do you think we'd be done with implementing rotated shapes, right? Not yet. There's also a translate attribute, and that actually includes matrix input. Matrices are basically a list. In this case, a list of floats containing information such as position data, skew data, and size data. Position values are easy because we can just use them as a delta or a shift and add them to the initial position of our object. Size values, however, will not be necessary. However, the skew value is complicated. They basically skew the shape on the x or y axis. However, Project Arrythmia does not have that functionality. But we need to get the skew values in order to get the rotation of the object. So I use this line of code to get the rotation from the skew values. Okay, so now colors. SVGs can have any color, however Project Arrythmia only has 10 colors. To solve this problem, the users can choose the colors they are using by putting them into a list. Then we check on each game object if the color attribute matches one of the colors in the list. If so, then that color is applied to the object. But if the color doesn't match, then the first color on the list will be applied instead. The app was going smoothly, however I realized that using the console is not going to be ideal for most users. So then I created another project with my Visual Studio solution that takes care of the user interface. I used Windows Presentation Forms for the UI, which uses extensible application markup language. At the start of the program, I inserted all the values from the input class to the UI. And then when the user was ready to export, I did the opposite and inserted the values from the UI back to the input class. I also thought that the user should receive some logs and information for debugging in the case that they have errors when running the application. So instead of praying to the console, I redirected the logs to a text box in my user interface. Now, you think we implemented everything, right? Wrong. Some paths are shapes that aren't even triangles, squares, or hexagons at all, so I have to convert those paths to multiple shapes that apt to resemble the original shape. There's two major components to this: filling the shape area and outlining the shape perimeter. So first, let's outline the shape. So how do we do that exactly? Well, an SVG path contains points. We can create a square game object at each of these points and give that game object an offset of x, -0.5, y, 0. This should make the game object resemble a line. But we have to figure out the distance between each of these points in order to scale our square properly, as well as the correct rotation of the square. Okay, so let's figure out scale first, specifically scale on the x-axis. I simply got the difference between two of the points by subtracting the current point from our next point. I put this difference in a vector 2 called target, then I got the magnitude or the length of our target. Look familiar? Pythagorean theorem. Apparently school is useful for some things. And for scale on the y-axis, I'll just take the size of the outline that came from the SVG stroke parameter. If it's null, then by default it's 1. So now that we figure out how to scale our rectangle, we need to figure out how to rotate our rectangle. We know that we want to get the rotation between the current point and the next point. However, we can't just figure out rotation by 2 points. We need 3 points. The center point, a vector representing the length of one axis, another vector representing the length of another axis. So we're actually figuring out rotation between two axes. So one axis is going to have 2 points, the center which is 0, 0, and the vector containing the difference between the current point and the next point. But then we need another axis. Let's put this on the x-axis representing 0 degrees. We know that the y is 0, but how long should the axis be? It should be the length of the difference between the current point and the next point, so that way both axes are the same length. So we'll use vector 2 magnitude or the Pythagorean theorem to get to the length of the first axis, and then set the x scale of our second axis to the length of our first axis. Then we can plug our points into this function, and boom, we have the rotation. And now we just need to send all these shapes generated into our GameObject data class, and that's path outlines for you. And here it is. It's definitely not perfect, but it's getting there. I wonder what's causing it. Wait, I hear footsteps. Sorry, I gotta turn off my camera for a second.
Hey, what about this iteration? Wait, what are you doing? I thought we were working on the Tokyo flu.
Okay, so I need your help. I may not be able to work on this for I don't know how long, so there's a GitHub in the description. If you want to contribute, just...
Who the heck are you talking to?
No one, why?
Just get back to work.
Anyway, jokes aside, there's actually a GitHub for this project. So if you want to contribute or test it out, you can if you want. The GitHub existed before I made this video, but I figured that it was better to turn it into an open source project instead of just me working on this my lonesome self. The reason why I probably didn't do this sooner was probably because of my trash code, but I cleaned it up now, so it shouldn't be so bad. But yeah, there's probably some bug or something broken in the project that I don't actually know about, and other things that I don't know how to implement, so feel free to check out the GitHub. What we could be working on next would be trying to fill in the area of a polygon. There's two ways that we could do this. We could split the polygon into triangles, or we could split the polygon into squares. Project Arrythmia does not have the functionality to skew objects to just triangles, so the latter will probably make more sense. So I guess that's all we can implement next. Anyway, if you enjoyed the video, feel free to subscribe. I'm gonna go back into my coding corner to suffer until the game jam's done. Until then, see ya.